Floating point arithmetics, possible unsafe reliance on specific comparison? The following Python code calculates the number of iterations to do stuff based on some variables. The variables will all be of the same type, that is only ints or floats or whatever. My concern is whether it will work correctly if the values are floats. I know enough to always consider the pitfalls of relying on exact float values. But I can't tell if the above is dangerous or not. I can use I equals int, round, A, B, C, D, but I am curious as to understand floats better. It all comes down to the following: A, B, C is an exact multiple of D, so I am relying on A, B, C, D to become a value I that I can subtract 1 from and get the expected number of iterations in the while loop, with the implied assumption that I equals 0 becomes true. That is, can calculated multiples like this be decremented by 1 to reach exactly 0? I would like to not only know if it is unsafe, but more importantly, what do I need to understand about floating point to resolve a question like this? If someone knows decisively whether this is safe or not, would it be possible to explain how so?
I will give you a language-agnostic answer. I don't really know Python. There are multiple potential problems in your code. Firstly, this. If A is, for example, 109, and B and C are both 1, then the answer will be 109, not 109 to 2. I'm assuming single precision float here. Then there's this. If numerator and denominator are numbers that can't be exactly represented in floating point, e.g. 0.3 and 0.1, then the result might not be an exact integer, it might be 3.0000001 instead of 3. Therefore, your loop will never terminate. Then there's this. Similarly to above, if I is currently 109, then the result of this operation will still be 109, so your loop will never terminate. Therefore, you should strongly consider performing all the calculations in integer arithmetic.
You can use the decimal module to get an idea of what hides between a floating point number such as 0.3. Note that Python 2.7 changed how floating point numbers are written, how repr f works, so that it now shows the shortest string that will give the same floating point number if you do floats. This means that repr 0.3 equals 0.3 in Python 2.7, but repr 0.3 equals 0.29999999999999999 in earlier versions. I'm mentioning this since it can confuse things further when you really want to see what's behind the numbers. Using the decimal module, we can see the error in a computation with floats. Here we might expect 2.0 to 1.1, /0.3 equals 3.0, but there is a small non-zero difference. However, if you do the computation with normal floating point numbers, then you do get 0. The result is rounded somewhere along the way since 1.85 times 10 to the power of negative 16 is non-zero. I'm unsure exactly where this rounding takes place. As for the loop termination in general, then there's one clue I can offer. For floats less than 253, IEEE 754 can represent all integers. The space between representable numbers is 2 from 253 to 254, as shown above. But if your I is an integer less than 253, then 1 will also be a representable integer and you will eventually hit 0.0, which is considered false in Python.
You're right that there could be a non-convergence on 0, at least for more iterations than you intend. Why not have your test be, while I is greater than or equal to 1? In that case, as with integers, if your I value dips below 1, the loop will end.
If you want an aborted demo, please consider locking this Friday.